This next video is a review for the vertex and the axis of symmetry. Just want to zoom in a little bit. I'm going to draw a picture of my parabola. Remember, the parabola is the graph. So if you have a U shape, this is called a parabola. And the equation is a quadratic equation. So I'm just going to draw on, I'll draw on this guy. As far as vocabulary goes, we have our roots right here. Or zeros. X-intercepts, that's what we did in the previous lesson. Right here is our vertex. It's either the high point or the low point. And I'm just going to say this vertex is the point 1, 3. Now, the axis of symmetry is the vertical line that cuts the parabola in half. Okay, so there's my invisible line, and the equation for the axis of symmetry is always x equals, and you steal the x number, x equals 1. So let's go through some of these. Whoops. Well, that stinks. My picture's off. No, it won't let me do it. Okay, good times. I've lost it. Alrighty. So question number 1 says, which parabola has an axis of symmetry of x equals 1? Well, I can tell you it's this guy. Because remember, the vertex was the point 1, 3. It crosses at x equals 1. If you look at the other ones, there's my writing from before. This axis of symmetry here is at -1. Not 1. Again, this axis of symmetry is at -1. And this one is at 2. For number 2, it says which equation represents the axis of symmetry of the graph of the parabola below. So here's our middle. So here's -5. So it's 1, 2. This is -3 right here. So let's look at our choices. Oh, this is tricky. So see, they have y equals -3, x equals -3. It's a vertical line, so it always has to be an x equals. Try the next few problems, come back and check your answers on the key. So for this section, these questions are a little bit trickier. It says identifying the vertex of a quadratic given an equation. So in this case, we don't have a graph. What you have to do is put that into y equals and then look at the graph on the graphing calculator. I think this whole first column has that. Let's go over here and take a look. Is it going to let me? No. Let's take a look at this section because this is trickier. The height of a swimmer's dive off of a 10-foot platform into a diving pool is modeled by this equation. Y equals 2x squared minus 12x plus 10. X represents the number of seconds since the swimmer left the diving board, and Y represents the number of feet above or below the water surface. What is the farthest depth below the water surface the swimmer will reach? So I'm going to pause this for a sec and bring up a different program. It's not the same graphing calculator that you guys use. So hopefully there we go. Hopefully you can see how this moved over. This is Desmos. I know some of you used it when we were remote. Remember, the problem is saying that you have a diver. So you're standing up on some platform or something. You dive in the water and you dive down and then you come back up. So what this represents right here, let me make this smaller. Okay, whoopsie, is our dive. The guy or gal is here. Hello. And then what happens is they jump off and they go down and then they go into the water, splash. Okay, yeah, there we go. That's a splash. And then they keep going down. And once they get here, they hit the bottom and then they stop coming up. And then once they get to the surface, they can breathe again. And there's a smile on her face. So let's go back and look at this question. What is the farthest depth below the water's surface the swimmer will reach? So when you're looking at these problems, the X, this right here is time. So let's say seconds, something like that. And then the Y is how high you are. So they started at 10 feet. They went all the way down. Well, this kind of makes sense. -5, -6, -7, -8. Yeah, if you dive from high enough, you're going to go about 8 feet under the water. So our answer isn't necessarily -8. It's 8. You don't say your depth of a swimming pool is -8 feet. You would say, oh, my swimming pool is 8 feet deep. So let's look at number 5. A model rocket is launched from ground level. Its height, h, meters above the ground, is a function of time, t seconds after launch, and is given by the equation h equals -4.9 t squared plus 68.6 t. What would be the maximum height? So that's your biggest y value. Now, you're going to do this on your graphing calculator, except you don't have a h equals, you have a y equals. So you're going to put y equals, this is a -4.9 x squared plus 68.6 x. You're not going to use t in the y equals, you use x. And your graph is going to be shaped somewhat like this, and you're going to find the highest part. So you can work through the rest of these, come back and check your answers on your answer key in class, and make sure if you have questions, you ask them.